Now we're going to extend our directional derivative into 3 independent variables. So in the past we've only tackled with 2. Now we're going to tackle with 3 independent variables. So let's try and find the directional derivative of this function in this direction at this particular point. So we've seen this before. If you want to find the directional derivative if you want to find the directional derivative of f in the direction of this vector, then take the product of the gradient vector and the unit vector. So we need to work out our unit vector. So looking at our vector, the magnitude of our unit vector is square root of 9. This whole thing here would be 9, so it would be 3. So so we're going to get our vector. We're going to get our vector and then divided by its magnitude, which is 3. So our unit vector is given by this. So now to work out the gradient vector, remember the gradient vector is you taking the partial derivative with respect to x, y, and z. So looking at our function, differentiate this with respect to x. That would then give us this thing here. And then so when you come to differentiate this, you can visualize it like this, to the power of a half, and then this comes down, the bubble stays intact, this gets minused by 1, and then you times the derivative of the bubble itself. Well, anyway, differentiate this with respect to x. That will then give you this, and then partially differentiate it with respect to y. That will then give you this. Partially differentiate it with respect to z. That will give you this. So now we need to evaluate it at our particular point. Well, at this particular point, it will be 1. It would be 1. And then at this particular point, so you would put this into the x here, and into the x, put this into the y, and put this into the z. That would then give you this thing here, and then at this particular point, fz would be this. So to work out our directional derivative, we need to take the dot product of so to work out our directional derivative in the direction of v. So we could use this if we want to. We could use this if we want to. These two vectors specify the same direction. So the unit vector and the vector itself. So it doesn't matter which one you use. It will be in the same direction. Evaluated at this particular point would be you taking the dot product of the gradient vector, which we just worked out here. This is 1. This is 2. 3 halves, and this would be a half. So that's our gradient vector. This is our unit vector. So taking the dot product, so this is just a scale. Well, I can take out a half here. Well, tidy this up. This will then give you this. So now this is a scalar amount, the scalar amount. Let's merge these two together to give you this. So really it boils down to you taking the dot product of these two vectors, which will be this times this, which will be this, and then this times this, and then this times this. That will then give you this. Well, the directional derivative in the direction of our vector at that particular point is given by -1. Okay.